The deadliest thing on Earth isn't a predator. It has no claws, no fangs, no venom. It can't outrun you, and it definitely can't outfight you. In fact, it doesn't fight you at all. It doesn't even know you exist. It's a single-celled parasite, smaller than a grain of pollen, and it needs a mosquito just to get from one body to the next. And this, more than any lion, shark, or snake, is the single deadliest thing humans have ever encountered.
For most of human history, nobody knew what it was. They just knew the pattern. Someone would fall ill near a swamp or a marsh or standing water, and days later a fever would come in waves, then chills, then fever again, over and over. The ancient Romans had a theory. They blamed the air itself, specifically the air near wetlands, which they believed carried something poisonous. They called it Malaria, bad air. That name stuck around for almost 2,000 years, long after the Roman Empire itself was gone.
Hippocrates wrote about these fevers in ancient Greece. Physicians across the Roman Empire, in India, in China, all separately recorded the same pattern. Nobody connected it to a mosquito. Why would they? A mosquito bite barely itches. The fever comes days later. There was no obvious link between a tiny bug and a life-threatening illness. So for centuries, people just avoided the swamps at night and hoped for the best. Then, in 1897, a British army surgeon named Ronald Ross was working in India, dissecting mosquitoes under a microscope, one at a time, searching for something nobody had ever proven existed. On August 20th, a date malaria researchers still sometimes call Mosquito Day, Ross finally found it. Inside the stomach of an Anopheles mosquito, he found the parasite at a specific stage of its life cycle, confirming exactly how it moved from one host to another. Not through bad air, through a bite. Ross won the Nobel Prize in 1902 for the discovery. It was one of the first times in history that an invisible killer had been caught, quite literally, in the act. Here's where the scale of this thing becomes hard to fully process. Some historians and epidemiologists have estimated that malaria may have killed close to half of every human being who has ever lived. That number is difficult to verify with total precision, since record-keeping across most of human history was patchy at best. But even the more conservative estimates place the death toll in the billions, spread across thousands of years, making it very plausibly the single deadliest disease humanity has ever faced. And this isn't just ancient history. According to the World Health Organization's most recent global report, malaria killed an estimated 610,000 people in 2024 alone. 95% of those deaths happened in Africa. Roughly 3 out of every 4 were children under the age of 5. This isn't a story about the distant past. It's a story about something still actively happening, right now, today, while you watch this. A killer operating at this scale for this long doesn't just take lives, it leaves fingerprints. And one of the strangest fingerprints it left behind is inside human DNA itself. There's a genetic trait called the sickle cell trait, common in parts of Africa, the Mediterranean, and South Asia, regions that also happen to overlap almost perfectly with historically high malaria risk. People who carry one copy of this gene produce some red blood cells shaped like a crescent instead of a normal disc. 2 copies of the gene causes a serious, painful disease. But one copy does something remarkable. It makes it significantly harder for the malaria parasite to survive and multiply inside your blood. In other words, evolution made a trade. A gene that causes real suffering in its more severe form still spread widely through entire populations because carrying just one copy gave a strong survival advantage against a disease that was killing people constantly, generation after generation. This is natural selection responding directly to a parasite in real time, written permanently into human genetics. Malaria didn't just kill people, it shaped who survived long enough to have children at all.
For most of human history, there was almost nothing you could do about any of this. Then came the first real weapon, and it came from tree bark. Indigenous peoples in the Andes, including Quechua communities in what is now Peru, had long used the bark of the cinchona tree to treat fevers. When European Jesuit missionaries encountered this remedy in the 1600s, they brought it back to Europe, where it became known simply as Jesuit's bark. Buried inside that bark was a compound we now call quinine, the first real effective treatment against malaria that Europe had ever had access to.
Quinine changed more than medicine. For centuries, large parts of tropical Africa and Asia had been effectively unreachable for extended European settlement because outsiders without any natural resistance died from malaria in devastating numbers. Quinine didn't cure malaria completely, but it made survival dramatically more likely. Colonial expansion into malaria-heavy regions accelerated directly because of it. A tree bark used by Andean communities for generations ended up reshaping global colonial history. The next major weapon looked for a while like it might end the fight entirely. In the 1940s, a chemical called DDT was found to be devastatingly effective at killing mosquitoes. Countries across Europe and North America sprayed it aggressively, and malaria, once endemic in parts of the southern United States and southern Europe, was functionally eliminated in those regions within just a few years. The chemist who discovered DDT's insecticidal properties, Paul Mueller, won the Nobel Prize in 1948. For a moment, it looked like humanity might have finally, permanently, won.
Then the cost of that weapon became clear. DDT didn't just kill mosquitoes. It built up in the environment, moved up the food chain, and caused serious ecological damage, especially to birds. In 1962, a book called Silent Spring by biologist Rachel Carson exposed the scale of that damage to the public, and DDT use was sharply restricted across much of the world not long after. The chemical that had nearly wiped out malaria in wealthy countries was pulled back, right as many of the poorest, hardest-hit countries were only beginning to gain access to it.
The next real breakthrough came not from a lab in Europe or America, but from a 400-year-old medical text. In the late 1960s, malaria was becoming resistant to existing drugs, and a Chinese research program led by a scientist named Tu Youyou was tasked with finding something new. Tu didn't start in a modern lab. She started by reading through ancient Chinese medical texts, looking for any historical remedy for fever that might hold a real answer. In one text, written in the 4th century, she found an old method for treating fevers using a plant called sweet wormwood, extracted using a specific low-temperature process that traditional lab extraction had accidentally been destroying. She adjusted the extraction method to match the ancient description exactly. The compound that emerged, later named artemisinin, turned out to be extraordinarily effective against the malaria parasite, including strains already resistant to older drugs. Tu Youyou won the Nobel Prize in 2015. The breakthrough that reshaped modern malaria treatment came from taking a 1,700-year-old instruction seriously, instead of assuming older knowledge had nothing left to teach. Today, the fight looks different again. Insecticide-treated bed nets are distributed by the hundreds of millions across the hardest-hit regions. 2 malaria vaccines are now being rolled out across dozens of countries, a genuine first in the history of this disease. Since the year 2000, the World Health Organization estimates that more than 14 million malaria deaths have been prevented worldwide. Real, measurable progress, against something that has been killing humans since before written history existed.
And yet, 610,000 people still died from it in a single year, the most recent year we have full data for. Most of them were children who hadn't yet had the chance to grow up.
So think back to where this started. Not a lion, not a shark, not anything with teeth or claws or speed. A parasite so small, it needs another living thing just to move at all. Riding inside a mosquito that most people barely notice landing on their skin. It has shaped which genes spread through entire populations. It has redirected the movement of empires. It has forced governments to wage chemical warfare against ecological collapse and sent a scientist back to a centuries-old text just to find an answer modern methods had missed. The deadliest thing humans have ever faced was never something you could see coming or fight back against directly. It was something small enough to ignore, patient enough to outlast empires, and it's still out there right now in exactly the kind of quiet, unnoticed moment that let it survive for so long in the first place.